Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
Problem 17 asks what the main ideas of Dalton's atomic theory are, and then how these ideas support the laws of conservation of mass and of definite proportions or constant composition. So the four main ideas of Dalton's law, first is that matter is made of atoms. And Dalton's law or theory suggests that atoms are indivisible. But science has since then discovered that that's not true. Of course, atoms are made up of electrons, protons, and neutrons, and then those particles are actually even further subdivided, but we won't go into that here. The second tenet says that all atoms of a given element are identical in mass and properties. So for instance, an atom of hydrogen always has one proton and it always has the same mass. And it always acts the same. It's always, a gas at room temperature, for instance. Number 3, compounds are combinations of different kinds of atoms. Oh my goodness. And finally, chemical reactions are the rearrangements of atoms. Instead of, for instance, atoms becoming atoms of other kinds of elements, which can't happen. And so the way that these 4 different rules sort of fit with the law of conservation of mass and the law of definite proportions is, first, the law of conservation of mass states that matter is neither created nor destroyed in chemical reactions. It's important to note here that Dalton's theory states that chemical reactions are simply involved in the rearrangements of atoms and not atoms of one element becoming atoms of another. And so this idea of rearrangement fits really nicely with the idea that reactions maintain all of the same atoms. Let's see. I'm running out of space here. So reactions maintain all of the same atoms that were there at the start, which means that the mass remains constant. The law of definite proportions, sometimes referred to as the law of constant composition, states that a given proportion of constituent atoms and a constant proportion of those atoms' masses is true of any given sample of a particular substance. So in line with the idea that matter is neither created nor destroyed in chemical reactions, but rearranged, when one substance becomes another in a chemical reaction, the types of atoms in those substances and their proportions is conserved. And so in line with really all of these ideas, the idea of definite proportions fits in here because the rearrangement of atoms in different chemical reactions maintains the number of atoms in the original substances. and thus maintains the proportions of those atoms from the starting substances to the final substances. And so together, these four rules here fit really nicely with the ideas of Dalton's predecessors, and that's what makes Dalton's atomic theory so compelling.